Hi dear all, welcome you all to brilliant group of institution. Hope you did Neet 2023, the chemistry, physics, bio paper very well. Here we are going to discuss the Neet 2023, the chemistry paper in detail. All the 50 questions we can discuss in detail and the answers. Question number 51. The stability of Cu2 plus is more than Cu plus 1 salts in aqueous solution. You know the chapter D and F block element, grade 12 chemistry, you may study that. Cu2 plus is more stable than Cu plus 1, or Cu plus 1, why it is unstable in aqueous solution, right? They are all Cu2 plus having more charge density. Cu2 plus having more charge density than what Cu plus 1. So Cu2 plus is highly soluble in water. That means it releases more hydration energy. So the main reason is what? Cu2 plus more stable than Cu plus 1 in water. That means that hydration energy is the reason. Cu2 plus having more hydration energy than Cu plus 1, because Cu2 plus having more charge density, it's have high ability to dissolve in water, which means it releases more hydration energy. So hydration energy is the reason why it is highly stable in aqueous solution. So question number 51, option number 2. Question number 52, which one is an example of heterogeneous catalysis? What do you mean by heterogeneous catalysis and homogeneous catalysis that you studied in the surface chemistry chapter, right? Grade 12. So these all heterogeneous catalysis mean if the reactants and catalyst are in different phase. If the reactants and catalysts are in same phase, it's called homogeneous catalysis. For example, that you studied in NCERT textbook itself, that is option third one, dear all. Combination between dinitrogen, which mean you know N2, and dihydrogen, that mean H2. You know very well, nitrogen and hydrogen when you combine, you will get what? Ammonia. N2 plus 3H2 gives 2NH3. This is called what? Haber process, right? Preparation of ammonia from dinitrogen and dihydrogen, what we call Haber process. In this preparation, what is the catalyst we are using, dear all? Finely divided iron as the catalyst. What is the state of the reactant nitrogen and hydrogen? This nitrogen gas, hydrogen gas, but the iron is a solid one. If the reactants and catalyst are in same phase, it's called homogeneous catalysis. If they are different phase, what it is called? Heterogeneous catalysis. So dear all, one of the example for heterogeneous catalysis is what? Option number 3. Next one. Question number 53, based from which chapter, dear all? The grade 11 chemistry, that which chapter? The 5th chapter, states of matter. In states of matter, you may study different laws regarding gases, Boyle's law, Charles' law, Avogadro's law, right? Here they're asking direct NCERT, the graphical representation. They're asking you, dear all, the Boyle's law graph. What is Boyle's law says that? Boyle's law says that pressure is inversely proportional to what? Volume. When you apply more pressure, volume of the gas decreases, right? Dear all, we can cut, that is option third one, we can cut it because the graph is pressure against temperature. No. Here the relation is what? Pressure against volume. And the pressure against 1 by V is given, right? Pressure against 1 by V. Pressure and volume are inversely proportional. Pressure 1 by V are directly proportional. Yes, pressure and 1 by V are directly proportional. This graph is okay. Even this graph we already cut, right? Because it's pressure against T. So pressure and 1 by V are directly proportional. Yes, the graph is okay. They given the temperature T3, T2, T1, different temperature, and they mention here this T3 is bigger. T3 is bigger than T2, T1 is smaller. Is it correct or not? Yes, dear all. You know pressure and temperature, how they related? Pressure and temperature are directly proportional. Pressure and temperature are directly proportional. See this high temperature, pressure is high. This low temperature, yes, pressure is low. So this is the correct graph, dear all, where Boyle's law says that pressure is inversely proportional to volume. Right? So pressure is directly proportional to 1 by V. Yes, directly proportional, and at a high temperature, high pressure is there. Yes, it's correct one. Why? What is wrong in option number 2? Pressure against 1 by V. Pressure against 1 by V should be directly proportional, right? This is inversely. What about pressure against V? Pressure against V, okay, this graph is okay, dear all. Pressure higher means volume lesser. pressure higher mean volume less. That's inversely proportional. It's okay. But this temperature, all of you observed here all. T1 they mention. T1 is mentioned top. See, this temperature is given is wrong. The T3, T1, T2, 3, the alignment is what? The arrangement is different. So, dear all, which is the correct graph? Pressure against 1 by V. This is the directly proportional, and at a high temperature, pressure should be high. Correct answer is option A. Next one. Question number 54, a assertion reasoning question. In 2023 chemistry NEET paper, the only few confusion with the assertion reason problems, right? Assertion is given, a reaction can have zero activation energy. Is it possible, dear all? A reaction can have zero activation energy. Basically, it is wrong because according to Arrhenius equation, K is equal to A into E raised to minus EA by RT from the chapter Chemical Kinetics. So, when rate constant is equal to Arrhenius factor into E raised to minus EA by RT, if the activation energy is zero, what happened to this equation, dear all? A into E raised to 0, that is K equal to A. Is it possible, dear all? Dear all, which means all the collisions leads to the formation of products. No, all the collisions not lead to the formation of product. Dear all, activation energy for a chemical reaction cannot be the zero one. So assertion is normally basically false. What is reason given? The minimum extra amount of energy absorbed by the reactant molecule so that their energy become equal or greater than threshold energy. What it is called? Yes, activation energy. Activation energy is the minimum amount of energy, right, that's required to make an effective collision. It should be equal or greater than what? Threshold energy. Yes, it's correct one. So assertion is wrong, reason is correct. So assertion false, reason correct. Option number 3 is the correct answer. Next one. Question number 55. In lysine extract, you may study lysine's test in the organic chemistry 11th grade. Lysine extract of an organic compound, both nitrogen and sulfur are present, which gives a blood red color with Fe3 plus ferric. You know, dear all, ferric ion Fe3 plus when combined with a thiocyanate SCN minus, it form a blood red colored complex. What it is? FeSCN2 plus. It's a determination, you know, lysine test. It's a determination of which one? Sodium and sulfur, whether it is present in a organic compound or not. Yes, dear all, when ferric and you treated with the thiocyanate, it will form ferric thiocyanate. Ferric thiocyanate. This is the ferric thiocyanate which having blood red color. What is the purpose of this test? To identify the presence of sodium and nitrogen and sulfur in a complex, organic complex. Next one. Consider the following reaction and identify the product. Just like a haloalkane, haloarene or alcohol chapter, we can consider this one. You know, a alcohol is given and HBr is given. What happened when alcohol treated with HBr? Normally we know when alcohol ROH treated with HBr, what happened here all? We will get RBr, haloalkanes, right? Same thing. But here the mechanism very careful, dear all. First step, you know, OH remove, you will get a carbocation, right? First step, you can able to see that. Let me write it completed here all. The compound is given CH3, CH3, then CH3. From the first step, if you cut this OH, what you will get? You will get a carbocation here. But you know, this is just a secondary carbocation, right? Because it's connected to 2 carbon. How you can make it? If you have a secondary carbocation, immediately don't try to bring the Br minus to this carbocation here all. Check it whether there is a chance to get tertiary or not. Yes, there is a chance. From the nearest carbon, you can transfer this hydrogen. What is the shift is called? 1,2 hydride shift. Right? 1,2 hydride shift will happen here all. From the nearest carbon, one hydrogen, if it transfer, what you will get? You will get CH3, CH3, CH2 and CH3. Now where is the new positive charge? Here. Now it is a tertiary carbocation. To this one, the Br minus will attack. So you will get the compound CH3, CBr, then CH3 and CH2. CH3 is the final product, dear all. What is the option? Option number 4. So dear all, whenever you're removing OH or halogen something, if you're making carbocation is the first step, please don't carry out the substitution, nucleophilic substitution immediately on the carbocation. First, you check it whether there is a chance to make it what? Primary to secondary or secondary maximum to tertiary or not. Either by 1,2 hydride shift or by 1,2 methyl shift. There is a hydrogen, so 1,2 hydrogen shift can be done and you will get tertiary carbocation. Next question, dear all. For a reaction, the rate is given, right? The rate is given as from the chapter again chemical kinetics, that is K into A square into B. The rate equation or rate expression is already given. What they are doing? This is the same NCERT type of question. When the initial concentration of A tripled, they're all A tripled means concentration A become 3A. And B remain the same, right? B concentration keeping the same. So what happened here all? This is the initial rate, right? When you increase the concentration of A 3 times 3 square, let me take it 9 outside. So 9 into K into A square into B, right? So this is the initial rate. Now the rate increased by 9 times, right? If you increase the concentration of A 3 times, the concentration or the rate of the reaction almost 9 times increased. So increased by a factor of 9. Option 2 is the answer. Next one, 58. Match the column. There are cork, diamond, fullerenes and graphite. These all things we studied in which chapter? That is in P block element grade 11. It's actually a deleted portion in this year for the theory part, but you know it's there in our NEET syllabus. Cork, you know, carbon we are using for what? Dear all, carbon we using for what? It's used as a reducing agent, right? It's used as a reducing agent. A we can match with the third one. And a diamond, you know, diamond means carbon where carbon connected other carbons by a tetrahedral structure where carbon is sp3 hybridized. So diamond is what? Carbon atoms are sp3 hybridized. That is B with the first one. A3B1, 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 that is option number 2. What about fullerene? You know, fullerene is a football like a cage like a structure, right? The fullerene belongs to the fourth one. And graphite, you know, graphite which means each carbon connected to what? One carbon connected to what? 3 carbon in a trigonal planar manner, and it's having a layered structure, and it is sp2 carbon where graphite is used as what? It's used as a lubricant. That's one of the application of what? Graphite. So overall answer is option 2 from the chapter P block element grade 11. Next one. Which one of the following statement is correct? All enzymes that utilize ATP in phosphate transfer require calcium as the cofactor. Is it? Dear all, no. Magnesium as the cofactor. It's a wrong statement. The bone is human body. In human body is an inert and unchanging substance. Is it correct? Wrong statement, right? Magnesium plays roles in neuromuscular function and interneuronal transmission. No, dear all, it's not the magnesium role, it's a calcium. Calcium plays the role. It's wrong. The daily requirement of magnesium and calcium in the human body, you may study 200 to 300 milligram. That's what? 0.2 to 0.3 gram. That is a correct statement. Option number 4. Next one. A compound is formed by solid state chapter, right? A compound is formed by 2 elements, A and B. The element B forms CCP. You know, CCP is nothing but what? FCC. Right? B forms CCP. You know, FCC, what is the number of atom per unit cell? 4. 4, right? So, B form cubic close packed structure, which means there are B, how many times, dear all? 4 times. Where A occupy 1/3 of tetrahedral void. Calculate the tetrahedral void, dear all. If the system is CCP, number of atom is 4. If the number of atom is 4, what is the octahedral void? Same number. What is the tetrahedral void? 2n. That means what? 2 into 4, 8. Yes or no? So, dear all, the system is in CCP. CCP is what? FCC, where number of atom per unit cell is what? 4. And then if the number of atom is 4, how many octahedral void will be there? Same amount. 4 octahedral void and 8 tetrahedral void. Double tetrahedral void will be there. Where A occupy 1/3 of tetrahedral void. So A is equal to what? 8/3, right? So B 4, and what about A? A is 8/3. right? How you can cut this denominator, dear all? You can multiply by 3, the both side you can multiply by 3, so it becomes A8 B12. While simplifying, it comes A2 B3. But what is the question? They're not asking the formula of the compound, right? If the formula of the compound is AX BY, then the value of X plus Y is, what is X plus Y? 2 plus 3, that's equal to 5. The answer is what? Answer is what? Option number 4. So from the chapter solid state again. Next one, homoleptic complex from the following complex is. What do you mean by homoleptic complex? If the complex contain only one type of ligand, from the chapter coordination complex grade 12. If the complex contain only one type of ligand, we call it as what? Homoleptic complex. Dear all, it's diamine chlorido. No need to go for that. There are 2 different type of ligand. It's heteroleptic. Pentaamine carbonato. See, there are different type of ligand. Triaqua, different type of ligand, heteroleptic. What about potassium trioxalato? Dear all, oxalato aluminate. Potassium is the cationic part, counter ion. Aluminate is the metal atom. Trioxalato, there is only one ligand, oxalato. So this is the homoleptic complex, option number 4 from the chapter coordination compound. Next one, what is the correct order of energy of molecular orbital of nitrogen molecule? From the chapter chemical bonding grade 11 MOT, molecular orbital theory, right? What molecular orbital theory is studied? It's only applicable for 2 systems, right? Up to 14 and more than 14. What is the equation you studied? Up to 14 electron system, dear all. That is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Yes, and after that what you have? Pi 2px is equal to pi 2py and sigma 2pz. Then you have their corresponding ABMO, pi star 2px equal to pi star 2py and sigma star 2pz. These are the arrangement of the molecular orbitals in the increasing order of energy up to 14 electron system. Here the system is given N2, nitrogen having 14 electron. So this is the arrangement of the molecular orbital. So can you able to say, dear all, which is correct? That's option 4. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Yes, they are equal. Yes, correct. This is the correct order. Just they are asking you, what is the molecular arrangement of molecular orbital for nitrogen molecules? So easy question. Next one, 63. Taking the stability of stability as a factor. Taking stability as a factor, which one of the following represent correct relationship? Dear all, indium, aluminium, thallium, right? They are belongs to which family? Boron family. Boron, aluminium, gallium, indium, thallium. So this question is from which chapter, dear all? That is from the P block element grade 11, 13th group. Boron, aluminium, gallium, indium, thallium is studied that boron family can exhibit 2 type of oxidation state, +3 and +1. Topmost element shows higher oxidation state, down it decreases. Stability of the higher oxidation state decreases down the group due to inert pair effect, right? Due to inert pair effect. So which is more stable among this one? They're all iron with iodine. So what charge? +3, here +1, right? And aluminium charge here +1, here +3. And thallium, here it is +1, here +3, here +3 and +1. Which is more stable, dear all? Dear all, thallium is located down the group, right? Down the group. Thallium, which oxidation state is more stable? +1. So thallium +1 is more stable than +3. Yes, third one is correct one. Is indium +3 stable? No, dear all. Indium +1 is most stable. If aluminium +1 stable? No, dear all. Aluminium topmost element +3 is stable. Thallium +3 stable? No, dear all. Thallium below +1 is stable. So option 3 is the answer from the chapter P block element, topic inert pair effect. Next one. Assertion reason, helium is used to dilute oxygen in diving apparatus. The scuba divers from the chapter solution, Henry's law. Scuba divers using helium filled oxygen cylinders, right? Why they're filling? Because it's a less soluble gas, right? Helium is used in a diving apparatus. Correct statement. Helium has high solubility in oxygen, is it? Helium is less soluble in our blood. Helium less soluble in water and all. So helium has less solubility in oxygen, not high solubility. It is wrong. So assertion correct, reason wrong. That is option number 2 from the chapter solution. Select the correct statement. Select the correct statement from the following. Atoms of all elements, Dalton's atomic theory and or the structure of atom, the basic part they are asking you. Chapter 11th grade, right? Atoms of all elements are composed of two fundamental particles. Is it correct, dear all? No. According to Thomson's model and the Dalton's atomic theory and all, atoms composed of basically three things, which are proton, neutron and electron, not two species. Mass of electron, 9.1 into 10 raised to minus 31 kilogram. It's correct. All the isotope, what is isotope? Same atomic number but different mass number. All the isotope of a given element show same chemical property. If you consider the isotope of hydrogen, protium, deuterium and tritium, same chemical properties, right? That's a correct statement. Protons and electrons are collectively called a nucleon. Dear all, it's a wrong statement. Protons and neutrons are called what? Nucleons, not electron. Wrong statement. Dalton's atomic theory regarded the atom as an ultimate particles of atom, right? It's a building block of every matter. Yes, correct one. So, which all are correct? That's a question. B, C, E are correct. B, C, E are correct. Next one. Which of the following statements are not from the chapter? Which one, dear all? Hydrogen from grade 11. Hydrogen is used to reduce heavy metal oxides to metal. Yes or no? Yes, hydrogen is used as a reducing agent. Heavy water is used to study reaction mechanism. Yes, read the sentence line by line, dear all. Heavy water used as for study of the reaction mechanism, and you may study the like a D2O heavy water that's used to what? The moderator in nuclear reactor and all. Hydrogen is used to make saturated fats from oil. Yes or no? Yes. These are all the applications of hydrogen from the chapter hydrogen. The HH bond dissociation energy is lowest as compared to a single bonded. Dear all, single bonded species, when you consider HH bond is, very well, it's very strong. So it requires more bonded dissociation energy, right? It's a wrong statement. And hydrogen reduces the oxides of metal that are more active than iron. No, as per the reactivity order, hydrogen is here, iron is here, metals are there. So they are saying that hydrogen can reduce the oxides of the metal which are lying above Fe. No, dear all, hydrogen can reduce the metal oxides only of the elements which are located below hydrogen, right? It's not possible because hydrogen above iron, all other elements above the hydrogen are more reactive. Hydrogen can't reduce it. So this is not the answer. It means D and E are wrong statement. That's what we need. So D and E only, that is the answer. Next one. The given compound from the chapter haloalkanes and haloarine, grade 12 chemistry, dear all. Very simple question. What is mean by aryl halide? Aryl halide means halogen directly present on a aromatic ring or a sp2 carbon, right? What about allylic halide? Allylic halide means halogen connected carbon sp3, then it's connected to what? sp2, again sp2. But vinylic means what? Halogen connected carbon sp2, again it connected to sp2. What do you mean by benzylic? Halogen connected to a sp3 carbon, then it's connected to a benzene ring, a phenyl ring. This is called what? The groups, specified groups. What type of group is this? Dear all, this is the halogen, this is an sp3 carbon, this is an sp2 carbon, this is again sp2 carbon. It is a format of what? Allylic halide. So answer is number 2 is the correct answer from the chapter haloalkanes and haloarine. A simple question again. Next one. Identify the product in the following reaction. A simple question, dear all. Zinc, amalgam and HCl. Which chapter? Aldehydes, ketones and carboxylic acid, right? Zinc, amalgam and HCl. Which reaction, dear all? Clemmensen reduction. What is happening in Clemmensen reduction? The aldehyde or ketone, right? The aldehyde or ketone part become what? That becomes hydrocarbon. The aldehyde or ketone part become what? Hydrocarbon. So your answer is ready, dear all. This CO becomes what? CH2. This CO becomes what? CH2. What is the answer, dear all? That is option number 4. Yes, CH2, CH2. If it is a Clemmensen reduction or Wolff-Kishner reduction, the aldehyde ketone part become what? Its corresponding alkane, hydrocarbon. Simple question. 4. The conductivity from the chapter which one? Electrochemistry, grade 12. The conductivity of centimolar, what is centimolar, right? 0.01 solution of KCl at 25 degrees Celsius is given. So dear all, conductivity means kappa, that is 0.210 ohm inverse or ohm inverse centimeter inverse. And the resistance of the cell is given. The resistance R is given, dear all, 60 ohm. What is the value of cell constant? That's a question. What is the relation between kappa, R and cell constant L by A? We studied kappa is equal to 1 by R into cell constant L by A. Substitute directly, dear all. 0.21 equal to 1 by 60 into L by A. We need to calculate the cell constant L by A. So L by A is equal to 0.21 into 6 into 60, right? So what is the answer, dear all? That is 2.1 into 6, that's equal to 0.21 into 60, that's equal to what? 1.26. So simple question from the chapter electrochemistry. Next one. Among the given option, which of the following molecule or ion act as a Lewis acid? From the chapter equilibrium, we studied what are Lewis acid and Lewis bases. What are Lewis acid, dear all? They are electron pair acceptors. Lewis bases are electron pair donors. Lewis acids are electron pair acceptors. They're all H2O, oxygen contain lone pair. They're electron rich, so they donate electron. They are Lewis base. What about BF3, dear all? BF3, when you consider the central atom boron connected to 3 bond means 6 electron. They not completed their octet, right? So they are electron deficient. BF3, AlCl3, these kind of species are electron deficient. So they will attract electron. Yes, they are called what? Lewis acid. Option number 2. OH minus, they are all minus indicate what? Electron richness. They can donate electron. They are Lewis base. Ammonia, nitrogen contain lone pair. They can donate electron. They are Lewis base. So option 1, 3, 4 are Lewis base. Option 2 is Lewis acid because it's electron deficient. Next one. Given below statement, a unit formed by the attachment of a base to one dash position. Dear all, which chapter? Biomolecule from grade 12 chemistry. First position of sugar. Sugar moiety. When you consider, dear all, when you consider the sugar moiety, here we have a pentose sugar, and these are the carbon 1, 2, 3, 4, 5, etc. If the first position connected to a base, if the pentose sugar first part connected to a base, what we call, dear all? It's a nucleoside. Yes, it's a correct statement, dear all. Let's go with the statement 1. It's correct. But when nucleoside, this is nucleoside, is linked to phosphorus acid at a 5' position. Dear all, 5' position is which one? Which one? This is a 5' position where H3PO4, right? When phosphorus acid, is it correct, dear all? No, phosphoric acid. Phosphoric acid is present there. Phosphoric acid, if it present here, if phosphoric acid, if it present, then what it is called? Nucleotide. But they mentioned what? Phosphorus acid. It is wrong, dear all. So assertion, so means statement correct, statement 2, 1 is correct, 2 is wrong. So 1 is true, reason is false. Option number 2. Next. The relation between, from the chapter structure of atom quantum number part, the relation between Nm, what is Nm? The permissible magnetic quantum number, okay, for a given value of azimuthal quantum number L. You know, from magnetic quantum number, how to calculate azimuthal quantum number? M is equal to 2L plus 1. This is a relation between magnetic and azimuthal quantum number, from which they are asking you, this is 2L square. No, it's wrong. M equal to 2L square. No, not correct. So what? Let me make it into L form. So 2L is equal to what? M minus 1. L is equal to what? M minus by 2. Where M they notated by Nm. So answer is what? Option number 4. So what is the relation between azimuthal quantum number and magnetic quantum number? M is equal to 2L plus 1 from the chapter structure of atom grade 11.